sir.
This type of friction is called static friction. Static because during this time the body is not moving. So during this time, static means during this straight line graph, the box is not moving. Clear? Clear? So I want someone to share her experience. If you have come across such an experience in life, that you wanted to push something, but it was not moving at all. So does anyone want to share this experience and tell us in short what had happened that day?
Sir, I'd like to share.
Yes, please.
So I was arranging my study room, no, sir, and then I had to push a cupboard so that I can keep that study table in more in area where there was more light.
Yes.
Daylight. But then I could not push that cupboard, so
Yes.
I had to take help from my family members.
Okay, to increase the applied force. Yes.
Yes, sir.
To increase the applied. So that time you were in this part of the graph. When the cupboard was not moving, you were in this part of the graph. Okay.
Yes, sir.
Yeah. Now, what would happen if the more family members are coming and I'm increasing the applied force? Please pay attention on the animation. Please pay attention on the animation. Actually, we should not call it animation. It is called simulation. So I am increasing to 39 not moving. Please pay attention. 49 not moving. 62 not moving. 17. Now see what happened. See what happened? Look at the friction force. Where did it get stuck?
49.
So when the Brixana's cupboard was not moving, the cupboard was demanding a force at least equal to or greater than 49 Newton. Understood?
Yes, sir.
The cupboard was demanding a force of at least 49 Newton or more than that. So maybe Brixana was able to give a force of 40 or 38 or 35. But when our family members came, then all of a sudden they got a force which is greater than the 49. And the box started moving. But interesting thing is, once the box started moving, that friction force, what did you see what happened? It suddenly remained constant. Understood? The friction force suddenly remained constant, although the applied force has increased.
Yes, sir.
Clear, everyone? So this is a very, very important concept that we need to understand. So let us see what is the maximum force the box is demanding. Maximum force the box is demanding. Oh, sorry. I reset the animation. So remember we had put it to here. Remember we had put it to here.
Yes, sir.
So when I reset the animation, it went back in the middle. So let me just reset, and then we will. Now will the box demand more than 49 or less than 49? Because I have reset and the slider has moved from 0.2 to somewhere here. So can anyone tell me, will the box now demand more than 49 or less than 49?
So more than 49.
More than 49. More than 49. Good. Because I have increased the mu And more mu means more of surface, and more of surface means we expect more friction. So let us check it live here. So I'll click the values. Yeah, so 80, 75, 75 not moving, 83, 83 not moving, 90, 90 not moving, static, static, 98, 98 not moving. Please pay attention and tell me, okay? 101 not moving, 108 not moving, 119 not moving. Did you see that? Did you see that?
Yes, sir.
So it is somewhere in the 90s. So you have to pay attention. 67 not moving, 72 not moving, 77 not moving, 85 not moving, 95 not moving, 98 not moving, 106 not moving, 111 not moving, 116 not moving, 129. There is very interesting thing happening here. If you have noticed here, till 116 it is not moving, but when it crossed around 121, when it crossed around 130, then it started moving. Did you see that animation?
Yes, sir.
Approximately 130 will keep it. What does that mean? So please listen very, very carefully. What does that mean? I'm going to finish the class in just a time. So the box will try to resist as much as possible up to some maximum value. The box will try to resist the motion up to some maximum value. In our case, it was like 130, but this graph is not matching here. But then I will just erase this 30 and just be patient with me, please. I will just erase this values here, here. And in our case, the maximum it was trying to resist was up to 130 approximately, because whether you watched it carefully or not, I don't know, but roughly it was trying to adjust up to 130. Clear?
Yes, sir.
Clear?
Yes, sir.
And this maximum up to which it can reach is called the limiting friction. Okay, maximum static friction has a special name. It's called limiting friction. Clear now?
Yes, sir.
But did you notice that something interesting happened once it crossed the maximum limiting friction? Once it crossed the maximum limiting friction, see, the friction reduced to 94. Did you observe that?
Yes, sir.
Observe that?
Yes.
So up to 119, it's not moving. Up now around 129, it started moving. But interestingly, the frictional force now decreased to 94. Understood?
Yes, sir.
Yeah. So our graph now will look something like this. So our graph will now slightly reduce. That after it reduces, then it becomes almost a constant. Clear now?
Oh, yes, sir.
Okay. Yeah.